Hello everyone. Today we're going to talk about temperature, not only how to measure temperature, but how to calculate different amounts of temperature for the different temperature scales. So in the PowerPoint, first you see obviously we use thermometers to measure temperature. And temperature is the measurement of how hot or how cold an object is. We all know that we've used or seen thermometers before in our life. If we've gone to a doctor's office, they measure our temperature. We also measure air temperature, as in humidity. It just depends on what scale you're talking about, because we're so used to degrees Fahrenheit in our pretty much everyday life. Outside it's 100 degrees when the weatherman tells us that. Well, he's talking about degrees Fahrenheit. Not a lot of people say the actual units to go with it. But in the lab, we use these type of thermometers that you see right here in the picture, and we use degrees Celsius. Well, in the AP test, it's mostly about Kelvin. So I'm sure you've heard of those three different temperature units before, but do you actually understand the difference between them? So I put a picture in here to show you the difference of numbers. As a normal body temperature is around 97, 98 degrees, but that's degrees Fahrenheit. But if it was Celsius, as you see on the other side of the thermometer, we're talking anywhere between 36 to 38 degrees. And over here for Fahrenheit versus degrees Celsius and Kelvin, well, Fahrenheit and Celsius, we call them degrees Fahrenheit, degrees Celsius, because we actually have thermometers out there that can measure those temperatures. So we call it degrees of that temperature scale. But Kelvin is not degrees Fahrenheit, because Kelvin is a calculation. It's a relationship from Celsius to get to that Kelvin. So I know you see a picture of a thermometer, but there is no such thing as a Kelvin thermometer. So a couple things to really point out here is we always usually in the lab talk about degrees Celsius, because that's what our thermometers are measured in. And water freezes at 0 degrees Celsius, but if you look at Fahrenheit, it's 32 degrees Fahrenheit. Or if water boils, it's 100 degrees Celsius, but in Fahrenheit, it's 212. But when you correlate Celsius to Kelvin, they actually change by a degree each time. Fahrenheit does it. It's an actual calculation to get from Fahrenheit to Celsius. Whereas if I went 1 degree Celsius, well, then that just means one more Kelvin. And if I go 2 degrees Celsius, well, then that's 2 more Kelvin. They change at the same time. So if degrees Celsius goes up 1, then Kelvin goes up 1. If this one goes up 1, and then that one goes up 1. Unfortunately, between Fahrenheit and Celsius, it's a calculation. But the good news is Fahrenheit's not on the AP test. So I'm not even going to go with that. But in my classroom on the wall, I have a thermometer that measures the air temperature, and that is degrees Fahrenheit. But I don't want to miss a lot of time with talking about Fahrenheit, because we're not tested on it on the AP test. But we are tested on Celsius, degrees Celsius, and Kelvin. So I did put the equations of Celsius and Fahrenheit, because as you see right there, it's not a very simple calculation where you just add and subtract something. You have to multiply, divide, and add, or multiply, divide, and subtract. So it's a little bit more complicated. So degrees Celsius, there's a couple values you should always know, especially when it correlates to water. When water freezes, when water boils, and especially this thing called room temperature. We love room temperature in AP Chem. And room temperature in AP Chem is 25 degrees Celsius. In the picture, you probably see around 21. Sometimes I've seen 23. But in AP Chem, it's 25 degrees Celsius. Okay? So in the next slide, as you see, is Kelvin. It's not a thermometer. It's a calculation. So this is the point I was trying to get with the picture. Every time you go up in Kelvin, I don't want to say degrees Kelvin, because it's not a degree. It's a calculation. Every time you go up 1, look at what happens with Celsius. It goes up by 1. And Kelvin went up another one to 280, and Celsius went up again to 6.85. It goes up 1 by 1 by 1 between these two calculation scales. So here are the two equations. And lucky for you, I believe they're on your AP equation sheet. I believe one of them is. I don't think both of them are. But to find Kelvin, we just take the degrees Celsius and add 273. Or if I want to rearrange my algebra skills, I'm going to take degrees Celsius, and I'm going to take that Kelvin minus 273. There are some textbooks that will put like a 0.15 at the end of it. There's no need to. Just add 273 to it. Okay. Another very important temperature out there, it's called absolute zero. And absolute zero is not 0 degrees Celsius, it's 0 Kelvin. And what happens is when you're at 0 Kelvin, well, think of that with the actual value it is with degrees Celsius. So if I know I have 0 Kelvin, well, if I know this, I have 0, something plus 273 has got to get me to that 0 Kelvin. What happens is you're talking about negative 273 degrees Celsius. That's extremely cold, extremely, extremely cold. I don't know what that is in Fahrenheit. I'd have to calculate it. But at that point in time, there is no molecule movement. There's nothing happening. You have completely just shut down the movement, the degrees of freedom of the molecules. That is the one point in time that you actually can do that. And it's called absolute zero, 0 Kelvin. So don't think that means okay, as you see right there. I've had students tell me that before. But as you see, virtually all motions of atoms and molecules and compounds, everything has completely stopped. So this is a topic in chemistry. It has to do with entropy, and you'll get to that later, definitely later, about chapter 19, third quarter-ish. You'll learn about degrees of freedom and movement. So in here, I just put a couple problems on here because I don't think we need to beat this topic to death. It's simply just adding or subtracting. So I want to put it in here. If you have a calculator, just do them real quick. I tell my students when you are solving for this, yes, you always need an equation. Okay. So if you have 0 degrees Celsius and I want to find Kelvin, well, obviously I'm going to use this very first one right here. So just always list the equation that you're going to use. So that way AP knows like what you're going to be using. But you don't have to show me how to take that 0 plus 273. Just do it. I just need to see the equation that you're using. And if you need to do that for yourself, that's fine too. So 0 plus 273. So what happens to the actual degree part? Well, when you substitute the number into the equation, it's gone. You're putting the value into that variable. So 0 plus 273, well then obviously that's just 273. Notice it's not degrees Kelvin, it's just Kelvin. And this is capital K. It's very important that you understand capital versus lowercase in chemistry. You're going to see the letter M used so many times in AP, capital and lowercase, and especially lowercase. We use it quite a bit lowercase. So it's very important that you distinguish between capital and lowercase. Part B, I have Kelvin, and I want to find Celsius. So obviously I'm going to use this second equation. So Celsius, Kelvin, and then minus 273. So I'm going to take this 45 and I'm going to substitute it in there. Like I said, if you need to show it, that's fine. But if you notice when you substitute it in there, let's remember a little bit of sig fig rules for adding and subtracting. When you add and subtract, the least after the decimal. Because, I mean, all we're doing with this calculation is just adding and subtracting. And it's the least after the decimal. Well, the cool part is, you see 273? It doesn't have anything after the decimal. So all of these calculations should not have anything after the decimal. So let me make sure I put that rule on there for you. So the least after the decimal, okay? So 45 minus 273, and you're probably thinking to yourself before you even plug it in, well, I'm going to get a negative number. And that's okay. You're going to get a negative number. You can actually get negative or positive numbers for degrees Celsius. But you cannot get anything but positive numbers for K. I mean, it doesn't make sense. Remember, we just talked about what's the lowest possible temperature for Kelvin? It's 0. There's no such thing as negative Kelvin. So make sure you don't make that mistake of thinking that Kelvin can be negative. Okay, Celsius definitely. Fahrenheit definitely. I mean, think of the East Coast. They're negative Fahrenheit all the time in the wintertime. But Kelvin is always positive. Okay. So for Celsius, negative 171, and I'm going to get to Kelvin, so obviously I'm going to use that very first equation up there, and I'm going to always list it, okay? So I'm going to plug that in. Now make sure when you plug that negative in, you're using the negative button, and right here on my calculator, if you guys can see, I'm using a graphy one. You can use a scientific. The negative button is right there. It's not this button over here. That's subtract. So make sure you're using the right dash button. Okay, so we're going to use that negative. So simply just plug it in, negative 171 plus that 273, and we know we better get a Kelvin that is positive. So negative 171, oops, 171. Sorry, having a little computer issues here. Okay, sorry about that. I think my batteries are getting ready to die. So Kelvin 102. Okay. All right. So 805 degrees Celsius. I'm going to go to Kelvin. So I'm simply just going to be adding 273. And I've already written the equation several times. So 805 plus 273. So it's a very, very simple calculation. Kelvin 1078. And notice what we said down here, sig fig rules, the least after the decimal. Even if I have a number that has something after the decimal, when you add 273, your answer is still not going to have anything after the decimal. So if I have 273 Kelvin, I want to get to Celsius, so I'm going to use this bottom equation. So degrees Celsius, when you write the unit, it is a capital C with a little degree. Think of it like a small o as an exponent in the corner. So I'm going to take that Kelvin and then 273 minus 273, so no brainer. That's going to be 0 degrees Celsius. Okay. And then the last one, yes, I have something after the decimal, but it's okay. So I'm going to find Kelvin. So I'm going to take that negative 32.2 degrees Celsius, and I'm going to add that 273. So this 273, nothing after the decimal, so you can still plug it in. Negative 37.2 plus 273. And I know in the calculator you're going to get 235.8. Now, we talked about rounding rules before. The number that you're going to cut it off with right there, if it's greater than 5, then you round it up. So I'm going to take this 5 and round it to a 6. Okay, so 236 Kelvin. Hope has been very helpful for you today. Ladies and gentlemen, just remember Kelvin, degrees Celsius. And there is a third scale out there, degree Fahrenheit, but it's not tested on the AP test. But I'm sure you learned it in CP or honors. It is important out there in our everyday lives, but we are not going to do any calculations with it throughout this course. Okay? Thank you, and see you on the next one.